factors, and welcome to my classroom. Today's video is structured much differently than the ones before. If you haven't watched the first video explaining the mole concept and how we use the mole in chemistry, do that first. This video is structured so that you can follow along with the practice problems. If you look in the video description, there's a link to a PDF. All of those questions or problems I'm going to be working through on my iPad so you can follow along. Feel free to fast forward through the video to find the question that you need help with, or just skip over the ones you don't. I would highly suggest work through the problems and then see if you get the same answer I did. Good luck!
So let's get started with these practice problems. Now remember, this PDF is available in the video description. It's also available on Blend, and I highly suggest that you work through the problems first and then follow along with the solution video to kind of check your work and then see where you might have misconceptions. Or if there was a problem that you got stuck on, I can help you find your way through it. But please make sure that you use the video for those purposes, not just to copy the work down, because that's not really going to be helpful to you. So let's go ahead and get started with number one. Number one says calculate the number of moles present in 74.9 micrograms of magnesium sulfate heptahydrate. Now you don't know the name, but that's okay. You'll learn it later. The first thing that I need to know is that this wants me to calculate moles, and I've been given a microgram. So I like to draw a little map of what I need to think through first. So I need to go from a microgram to the base unit grams and then to moles. Now I know the conversion from micrograms to grams. There's 10 to the 6 micrograms in 1 gram. That means 1,000,000 micrograms for every gram. Now in order to go from grams to moles, I need to know the molar mass of the compound. Now remember, the molar mass we calculate by adding up the individual molar masses of each of the elements. So let's go ahead and do that. So magnesium, if I look at my handy dandy little periodic table, is 24.305. I see that sulfur is 32.06. Oxygen is 15.999 times 4. And then I'm going to do, let's see, 7 times 2 times 1.008 plus 15.999 for the heptahydrate. So I'm going to add these, and then add it to this. That's a plus sign, not a multiplication. Okay, let me grab my calculator. So 24.305, 32.06 plus 15.999. Okay, and I get the molar mass is 246.466 grams per mole. Awesome, molar mass. Now I just need to set up my train tracks in order to convert each time. So if I look at 74.9 micrograms, my first train track is going to be converting from micrograms to grams. Want, have, conversion 1 over 10 to the 6th, 1,000,000. My second conversion, now remember, of course, you can do these in 2 steps if you'd like. My second conversion then is going to be moles over a gram. And I know that 1 mole has what we calculated, 246.466. Awesome. Now if I put that in my calculator, that's the same thing as saying 74.9 divided by 10 to the 6th divided by 246.466. Always make sure if you're using division in your calculator that you put them in parentheses just so that you don't get a division error. Now I also want to cover this just in case some people get a little confused on this. Hopefully we've clarified it now. The calculator tells me that the answer is 3.0389 negative 9. Now all that means is the E, remember, means times 10. So I already know that this means 3.0389 times 10 to the negative 9th, and my unit was moles. Awesome. Now there's also something wrong with that, is I still have to take into account significant figures. So if I look at my problem, 74.9 has 3 sig figs. I've done nothing but multiplication, so my answer should also have 3 sig figs. So let's fix that. 3.03 0.04 times 10 negative, almost wrote the fourth, moles. And this should be your answer. Awesome. We've done one problem. Now let's keep going. Number 2 says calculate the grams present in 1.4 moles of calcium chloride. So let's again map. We want grams, we have moles. So I'm going from moles to grams. And I can go directly to that by using the molar mass. So I just need to calculate the molar mass of calcium chloride. Now I'm not going to write it out this time. I just wanted to do it once so that you could see it. So let's see, 0.78 plus 35.45 times 2. So the molar mass of calcium chloride is 110.978 grams per mole. Molar mass is always grams per mole. Note units. So now I just need to set up my train tracks again, 1.4 moles. This luckily is a one-step problem. That's always a good one. Grams to moles. Grams in this case is what we calculated, 110978, and that's per 1 mole. So then we just need to multiply it by 1.4, and we get that the answer is 155.3692 grams. Now, of course, that's not the correct sig figs. My answer gave me 2. Now, this is where you have an option. So 2 sig figs. So if I think about if I truncate all the decimal places, students kind of get a little messed up with what to do with this 5 here. And what you can do is 2 options. So 1, it's on a 5, so I need to round to the nearest even number. So that means this should be 6. So I could write it as 160 grams. Now that's the correct sig figs because I didn't put a decimal place. You could also write it in scientific notation as 1.6 times 10 to the second grams, whichever, but please be mindful that blend doesn't know the difference unless we tell it. So if we ask for ordinary, this one. If we ask for scientific notation, that one. 2 down. On to the next one. Number 3. Now this is when we're using Avogadro's number. So calculate the number of molecules in a 3.52 gram sample of sodium hydroxide, NaOH. So again, I'm going from grams. Now I'm going to molecules this time. So from grams to molecules, I can't go directly to that. I have to use that connector piece that we talked about, which is the mole. And then I can go to molecules. Just like that. Now, in order for it to go to grams to mole, I again need the molar mass. So let me go ahead and grab that for NaOH. So that's 22.990 plus 15.99608. Awesome. So that is 39.997 grams per mole. Sweet. Now we have, let's set up our train tracks. 3.52 grams. Whoops, sorry. Shift this a little bit back over here. Grams. We need to go to moles first. 1 mole. 39.997 grams. Now here's the little trick. So moles is abbreviated MOL. Don't confuse that with molecules. So mole on the bottom, molecules on top. That's why I'm going to write it out so that you can see it. 1 mole, this is Avogadro's number, so 6.022 times 10 to the 23rd. That's that connector piece between a mole and a molecule. So now we just need to do the math. 3.52 divided by 39.997 times 6.022 23. Awesome. So now my answer has 3 sig figs, or my problem gave me 3 sig figs, so my answer needs 3 sig figs, so it should be 5.30 times 10 to the 22nd molecules. Perfect. We're on a roll. Let me double check that I got this one right because I started to second guess myself. No, we're right. 2 more. Now this is where students get a little mixed up, is when we have to go to atoms. Now atoms, you need to think about each molecule individually. So let me just write out first the map. So we start with moles. We then go to molecules, because we have to know how many of these little doodaddies we have. And then we go to atoms. Then we need to know how many each of those doodaddies, how many atoms each doodaddy has. Sorry there, that was a tongue twister. Now, luckily this time I don't need to convert any, I don't need any molecular mass because it's irrelevant because I'm already in moles. So I need to go train tracks, 3.5 moles. What I want now is molecules. First, over a mole, 1, Avogadro's number. After doing it so many times, you'll probably have that number memorized, if not already. Okay, now here's the trick part. I need to know how many, for each molecule, how many atoms. So this problem asks me for the total number of atoms. So that means I need to know how many atoms for each molecule. So, well, each molecule has 1 copper, just like we did in Unit 1. 2 nitrogen, so I have to apply that to parentheses, and 6 oxygen atoms. So that means in total, that's 6, 7, 8, 9 atoms in total per molecule. And then we're set. Now, please make sure that you're applying the parentheses because that's normally where students mess up, or they completely forget to do this step of 9 over 1 altogether. So make sure that you have to also include how many molecules of each you need. So let's see, how many sig figs we need? 2. So this is going to be 1.9 times 10 to the 25th. What unit are we in? Forgot. Atoms. And if you need help with that or you need extra practice problems with this, please let me know. I'm happy to provide some extra support there because I know that Adams one, that's normally the challenge question. Now, of course, this last problem, number 5, also has a challenge in it. In this case, we're going all the way from a volume measurement to hydrogen atoms. And that's quite a few steps. So first, we're going from liters. Then we need to go to grams. Whoops, sorry. And then we need to go to moles. Then we need to go to molecules. Then we need to go to atoms of hydrogen. Yeah, that's quite a bit of steps. That's okay though. It's the same process. I just have to do it more than one time. Now, let's talk about some connection pieces. I'm going to switch colors just for a second because this is where students get this. This we know. This is Avogadro. This is molar mass. The problem that students mess up is what is this connection? Now that connection piece is density. Now I'm realizing here that I already have this in liters. Now I would probably add a step here that we need to convert it to milliliters first and then convert to grams because we know that the density is 1 gram per milliliter. Just to make things a little straightforward in terms of that calculation. So let's do this first. We need the molar mass of water to make the calculation happen. So let's do that. 15.999 plus 1.008 times 2. So that's 18. You would think I would know this by my heart. I know that it's 18, but I don't ever remember the decimal place. Mole. Now let's set up the steps. So we need to go from long train tracks here. 0.23 liters. I'm just going to draw this way out here. Let's convert it to milliliters first. 1,000 per liter. Then we just need to use the density of water. Luckily, the density for water in this case, or I mean, in any case, is easy. It's 1 gram per 1 milliliter. Awesome. If you had another substance and we provided you the density, you would just have to change that value. 1 gram per milliliter. Next, we need to go to moles. So moles, 1 mole, molar mass we calculated, 18.015 grams. Now we're in moles, so we need to go to molecules. So that's Avogadro, 6.22 10 to the 23rd. I'm going to write MOL dot so that you know. 1 mole, no dot. I'm running out of space. And then I just need to do atoms. So 1 molecule here has how many hydrogen atoms? Well, water's formula is H2O, right? So that means it has 2 H's, so it should be 2 atoms per molecule. Awesome. See, now that was a lot of steps. However, it was the same exact process. So let's do all that math. So 0.23. Sorry while I type here on my calculator. Okay, so I got the answer is 1 point. Let's see how many sig figs. So my answer gave me 2. That leading 0 doesn't count, so I need 2. So it should be 1.5 times 10 to the 25th hydrogen atoms. And there you have it. That's some of the complicated questions for you to work through. So definitely check over your work, see where you had a mistake at all. Of course, if you're stuck and you're not sure where to go, feel free to reach out for extra videos or support. Also, ask your teacher, and we can definitely go through the steps again as well. But thanks for tuning in.
Great work working through those problems with me. I hope that helped you understand some of the various different ways we can ask you to calculate and convert using this unit of the mole. If you need any help or any questions about that, please reach out to your teacher and we're happy to explain more. Thanks for tuning in.